Hello, good morning, students. I am Dr. Sunita Tandon from RR College, Alwar. Today, I am going to start a new unit of Physical Chemistry special paper of M.SC final, and this is Chemical Dynamics. First part of this unit you have studied in detail in environmental chemistry subject in case of in environmental chemistry paper. So we are starting with the cycle, with the topic which is not covered under that unit. So first I am starting with unit 1, lecture 1. First is NOx cycle. The catalytic cycle involving nitric oxide NO and nitrogen dioxide NO2, collectively called NOx cycle, and provides one of the important destruction process for ozone. The process accounts for some 60 to 70% at the rate of destruction of ozone. The NOx reactions occurs in the lower atmosphere. Third, corrosion. First, highlight one importance of naturally occurring nitrogen oxide in the ozone removal process due to the following reasons. The following reactions, Nitric oxide reacts with ozone to form NO2 plus oxygen, equation number 1. This NO2 combines with oxygen to form NO and O2 in reaction 2. And net reaction of the two is oxygen plus ozone. It gives you 2O2. Clearly, this process produces the same net result as obtained in chemical composition at atmosphere, but the overall rate for the NOx cycle is faster. The main source of stratospheric NOx is the reaction of excited oxygen atom in 1D state with nitrous oxide. So, in next reaction number 3, oxygen 1D means it is representing its excited state. Oxygen in 1D state reacts with N2O to form 2 nitric oxides. N2O is produced at Earth's surface by bacteria in soil and water. Although most of nitrous oxides is photodissociation into nitrogen and oxygen. About 5% reacts with excited oxygen atom O1D to yield nitric oxide, thereby activating the NOx cycle. There are other minor sources of NOx. Cosmic rays, which enters the Earth's atmosphere, contribute to the production in the altitude range of 10 to 13 kilometers. Ionization reactions involving N2 also leads to the production of NOx is removed by reacting with hydroxyl radicals via the reaction. OH reacts with NO2 and a third body collision M, and it gives rise to HNO3 plus M. This is equation number 4. And HNO3 absorbs light and is converted into OH ions and NO2. This is reaction number 5. Reaction 5 binds about 40% at the NOx into HNO3, which is inactive in regards to ozone removal, and is transported onwards into the troposphere, where it is rapidly removed by rain, thereby returning the nitrate to the soil. Next, to assess the rate of these reactions, we primarily interested in those reactions which will change the total odd oxygen concentration. Odd oxygen concentration is oxygen atom plus ozone concentration. The significant reactions are as follows. First है oxygen absorb one quantum of radiations with a rate constant K1 or Ji and is converted into 2 oxygen. This is reaction number 1. Oxygen combines with oxygen molecule and third molecule M with rate constant K2 to form O3 and M. O3 then again absorbs one radiation quantum of radiation with rate constant K3 is converted into oxygen and oxygen atom. Oxygen atom and ozone then combine to form with rate constant K4 2O2. ये first, two, second, third reactions are of same type. Next is NO react with O3 and with rate constant K5 is converted into NO2 plus oxygen. In the sixth reaction, NO2 reacts with odd oxygen and with rate constant K6 is converted into NO plus NO2. NO plus O2. In next reaction, NO2 which is formed absorbs one quantum of radiation with rate constant J1 or K7 and is converted into NO plus O. These 5, 6, 7 are of reactions are of NO2 reactions. First are of oxygen and ozone reactions. Now NO plus OH with rate constants K8 gives you H2O plus oxygen, reaction number 8. Oxygen atom reacts with water, HO2, not water, HO2 with K rate constant 9 to form OH plus O2, reaction number 9. Then oxygen react with OH and K10 rate constant converted into H into O2. These 8, 9, 10 are reactions for OH ions. First 3 are for ozone and oxygen and 5, 6, 7 are for NO or NO2. These reactions are known as Chapman's reaction. The rate determining expression for OH, H and NO. All these are intermediate species. OH, H and NO are as follows. First है rate of formation of OH ions. देखो OH ions कहाँ कहाँ पर बन रहे हैं. OH ions बन रहे हैं आपके 9th स्टेप के अंदर. ठीक है, 9th स्टेप के अंदर बन रहे हैं, 10th में रिमूव हो रहे हैं और 8th में रिमूव हो रहे हैं. तो 8, 9, 10 ये तीनों इक्वेशंस यूज होंगी टू शो द कंसंट्रेशन ऑफ OH ion. तो डी बाई डी टी ऑफ OH इज इक्वल टू माइनस K8 OH ion प्लस ओजोन प्लस K9 into oxygen concentration into HO2 concentration minus K10 into concentration of O and concentration of OH. स्टडी स्टेट कॉन्सेप्ट हमने यहाँ पे अप्लाई किया है. ठीक है. सिमिलरली फॉर डी बाई डी टी ऑफ एच, एच कहाँ बन रहा है आप देखिए, केवल 10th इक्वेशन में एच बन रहा है. सो डी बाई डी टी ऑफ एच इज इक्वल टू K10 इंटू O इंटू OH concentration. This is equation number 12. Now equation for d by dt of NO. This is equal to NO. आप देखिए फिफ्थ स्टेप के अंदर डिसअपियर हो रहा है, 6th में और 7th में बन रहा है. तो हम क्या लिख सकते हैं, K5 माइनस K5 इंटू कंसनट्रेशन ऑफ NO इंटू कंसनट्रेशन ऑफ ओजोन प्लस K6 इंटू कंसनट्रेशन ऑफ NO2 इंटू कंसनट्रेशन ऑफ O प्लस Ji इंटू कंसनट्रेशन ऑफ NO2. एंड दिस इज इक्वेशन नंबर 13. फ्रॉम इक्वेशन 11, 12 एंड 13, on applying steady state approximation, we get that K8OH into ozone concentration plus K10 into oxygen into OH concentration is equal to K9 into O into water HO2 concentration. Question number 14. Similarly, for oxygen and OH, K10 is equal to O into OH concentration is equal to 0. And K8 into OH ion concentration into ozone concentration is equal to K9 into O into HO2. ठीक है. Now 16th equation is K5. This is for NO. K5NO into ozone concentration is equal to K6 NO2O plus Ji into concentration of NO2. This is equation number 16. The total odd oxygen concentration is given by d by dt of O plus d by dt of ozone, या d by dt of oxygen plus ozone concentration. This is given by equation 2Ji into oxygen concentration minus 2K4 into ozone into oxygen concentration, atomic oxygen, minus K5 into NO into ozone concentration minus K6 up into NO2 into oxygen concentration plus K7 or Ji into concentration of NO2 minus K8 into concentration of oxygen and concentration of ozone. Put value of K5NO and O3 concentration above equation, and on solving we get equation number 18. Upper equation is 17. Its steady state condition for OH and H and NO are assumed, then total oxygen concentration can be rewritten as d by dt of O into O plus ozone concentration is equal to 2ji into oxygen concentration minus 2 oxygen concentration common निकाल लिया, अंदर आ गया K4 into ozone plus K6 into NO2 plus K9 into water concentration. The magnitude of K4 O3 is calculated to be the order of some K6 NO2 plus K9 HO2. The NOx cycle is more important in limiting the dynamic balance of ozone than the HOx cycle, since the ratio C6 upon NO2 and K6 upon NO2 and K9 upon HO2, which determines the relative importance of the nitrogen oxide and hydroxyl species, is greater than unity. Thank you, students. I think you have understood the chapter and the topic, and we will study other things later on.